Hey everyone, we're about to cover some of the fundamentals of MicroPython, basically Python. I just wanted to be upfront and say that this is not a tutorial that teaches you how to code. There are plenty of resources online for that. This is more of a how do you do certain things in MicroPython compared to how you would normally do it if you're using C++. It's not a deep dive. I'm not going to go down into the intricacies of a lot of this stuff. Again, there's plenty of reference online for that. I'm going to be using my tiny Pico and I'll be coding directly in the REPL. So let's get started. First thing, let's RShell to the tiny Pico and let's go into the REPL. The first thing I want to cover is variable scope. It's pretty basic, but it's a little bit different to what you might be used to. In MicroPython, anything that's declared in the main body of your code is considered to be a global variable, and any variables created or referenced inside of a function is always considered to be local to the function unless you specify otherwise. So for instance, if I say x equals 10, just quickly, a nice thing in MicroPython is for me to check what value is in x, I don't have to do print x. I can actually just type x, hit enter, and it'll give me the value in there. And that's for any variable. Okay, if I create a function called test, you've seen me do this in a previous video, and I say x equals 20, print x, and then I run test, it equals 20. And you think, okay, that makes sense because x did equal 10, now x equals 20, right? But if I do x, enter, x still equals 10. The global space variable x equals 10. Inside test, I created a variable called x, which equaled 20, and printed it. So if I make the global version x equals 55, and I run test again, 20, if I print x, x is 55. So how do we use x in the global space inside our function? What we do is we def test, we tell the function that there is a global variable called x. Now we say x equals 20 and print x. So now when I type in test, x equals 20, and when I type x, x also equals 20. So you need to explicitly state which variables inside your functions are global variables. Okay, now that we've got that out of the way, let's look at some basic for loops. You might be used to this syntax to get a loop going from 0 to 9, or if we wanted to include 10, we'd do that, right? Yeah, no, none of that in MicroPython. For loops in MicroPython are as simple as this. For I in range 0, 11. Because we want to have the value go from 0 to 10, and the first value is inclusive and the second value is exclusive. We'll then say colon. Now I can print I. And we have our for loop. It's pretty cool, huh? What's if we wanted to count but skip every second? So I'm just using the up arrow to go through my history, so I don't have to type it all in again. We can add an extra value, which is the step. And now do print I, we get every second. Okay, what about going backwards? Well, we can say I want to go from 10 to 0. In this case, it'll be non-inclusive and -1. Put the print. We're now going backwards, 10 to 1. So for loops are really easy inside MicroPython. Now you've seen me do while loops in a previous video if you want to do either endless loops or if you want to do a loop that has much fancier calculations to do with the condition or multiple conditions. But what you can also do with a for loop is you can say for I in, and instead of using range, you can just make a collection of values. So in 1, 5, -10, 50, 100, 33. And now I can say print I, and that iterates through that collection of values. So it doesn't have to be a range that goes up in any particular sequence or down in any particular sequence. It can actually be just an arbitrary set of numbers. What's more is you can do this. I in hello Fred 100 3.412 by print I. That's now iterating through that collection of data, and it doesn't really care what's inside it. How cool is that? Now let's have a look at conditional statements, if, then, else. So in MicroPython, the if, else sequence is the same as any other language, except the syntax is a little bit different. Let's start off with x equals 15. Now MicroPython can use equal equal or not equal, but there's a more Pythonic way of doing it. Yes, Pythonic is actually a word. So we can say if x is 10, print we got 10. Now to do an else if, you use elif instead. Elif x is 15, print we got it, else print not here. Okay, and we got it because obviously x is 15. So rather than saying if x equals 10, we say if x is 10. By the same token, we can say if x is not 25, print boo-hoo. And we get boo-hoo because x is not 25. You can have as many elifs as you want. So you could do if x equals 10, elif x equals 11, elif x equals 12. You can also do multiple conditions within the same if or elif. So we can say if x is 10 or x is 20, print 10 or 20. Elif x is not 15 and 1 is 2. No idea. Else print the end. And we get the end because x is not 10 or 20 and x is not 15 and 1 is not 2. Wow, a little confusing. But as you can see here, it's the same type of syntax as normal. It just reads more like English and less cryptic with all sorts of symbols. Neither MicroPython or Python have a switch statement, but there are some creative ways that you can implement something similar. But that's out of scope for this tutorial. Let's have a quick look at strings. Strings in Python are very powerful. I can say s equals hello there, how cool is MicroPython? If I could spell, would be awesome. So obviously I can hit S and it'll print out what it is. In MicroPython you can interchange double quotes or single quotes. You can't mix them, so you can't start it with a single quote and end with a double quote, but you can use either. So string manipulation in MicroPython is really powerful. For instance, I can just say S and then I can use square brackets like I'm referencing an array, and I can do 0:10, and that's going to give me the first 10 characters of the string. What I can also do is say S square brackets, and I can say give me from 5, and then put nothing at the other end, and that's going to give me from position 5 all the way to the end. So what this is basically doing is allowing me to do a substring that you would normally see inside C++. Now with my if statements, I can do things like if cool in S, print it is cool, else print too hot. And it says it is cool because it found cool, the string, inside that string. I can also ask it for the index of a particular value. So I could say I equals s.index, and I can give it the word cool, and now I can say what is in I? 17. So cool starts at position 17. So the same as doing an index at. So it's quite powerful, but quite easy to use. So in MicroPython there is a whole lot of different types of collections. There are ranges, as you saw already. There are lists and other things. So let's have a look at what a list is. A list is an ordered set of arbitrary values. So I can say L equals, use square braces for a list. I'm going to say 1, 2, 3, 4.5. So I now have a list. I can hit L and it'll actually print the list for me. I can also do L and position 2, and that references index 2 of the list, obviously starting at 0. Now what's nice about a list is it's mutable, which means you can change values inside the list once it's been created. So I can actually say L2 equals lowercase 3. And now I can do the same thing and print it. And if I just print L, you can see it's lowercase 3. So once the data is in there, you can manipulate it afterwards. What you can also do is add lists together. So I can say L equals A, B plus L. So now when I print it out, you'll see A and B have been appended to the start of the list. I could also have done it the other way around and put it to the end. So you can join lists together. You can also append or insert or remove items in a list. So if I look inside L, you can see AB 1, 2, 3, 4.5. Let's say I want to remove the 2. So I can just say L dot remove, and I pass it the object I want to remove, not the index. So I want to remove 2. Now when I print it out, the 2's gone. I can also L dot remove 3. And now 3's gone. I can also insert. So I can say L dot insert, and you tell it the position it's going to go into. So I want to put something between B and 1. So that's position 2. So I'm going to say 2, and then I'm going to insert high. And now I've inserted something inside the list. I can also just append, L dot append Sion. And Sion's been added to the end. So lots of ways to manipulate lists. You can even have lists inside lists. So I can actually say L dot insert at position 3, I'm going to put 1, 2, 3. And now when I look inside, there's a list inside my list. How cool is that? You can embed it as deep as you want to go. I'm not sure how deep. I'm sure it's not endless, but you can definitely go a few levels deep. So now that we have a list, we can again do a for loop for I in L, print I, and we can iterate through what's inside the list inside our for loop. Or we can reference them directly via index, L4, which is 1. Now what's cool about a list is you can also include objects inside them. So an object could be a class reference, or it could be a function. You can make a list that has a whole bunch of different functions in it, and you can then call those functions by referencing the index of the list. Or you can call the functions in order by going through a loop of them. Very cool. Okay, let's talk about another type of collection. It's called a tuple. Now, tuples are very powerful, but it might not seem so at first glance. A tuple is just designated like this, 1, 2, 5, for instance. Go enter, that's a tuple. What's nice about that is it kind of works at this level just like a list. So if I said t equals 1, 2, 5 and print t, you can see what's inside it. I can print t1 and it just gives me the 2. That's fine. But what a tuple allows you to do, which I think is its main strength, maybe I don't know enough about them, there could be more, but you can pass many results out of a function using a tuple. And you can do it in quite interesting ways. So for instance, I might create a function that's called getAccel. Let's say I was getting accelerometer data back from my Tiny Pico play shield. And then what I can do inside is get all my data however I do it. For now, I'll just pretend that I got it from the device, but I'll say AX equals 100, accelerometer Y equals 50, and maybe accelerometer Z equals -25. Now, if I wanted to get all those 3 values out of a function normally, that would be quite difficult in most other languages. But what I can do here is I can say return, and inside these brackets, I can create a tuple. I can go A underscore X, comma, A underscore Y, comma, A underscore Z. So now I've got a function called getAccel. And what this allows me to do is something like X, comma, Y, comma, Z equals, I can say getAccel. And now, if I look at what's in X, X is 100, Y is 50, Z is -25. I've now got those variables that I can manipulate and use in the rest of my code, and I've done that just by returning 3 values for my function. That is really cool. Now, tuples are immutable, which means once it's been created, you can't modify it. If you remember, we've got t above, 1, 2, 5. I can't say t1 equals 7. Right? That's not possible because you can't assign to it once it's been created. You can't extend it, you can't shrink it, you can't do anything with it. it's fixed. A tuple can have, I guess, one or more value in it. I don't know why you do a single tuple. If you want to do a single tuple, you do something like s equals 4, and you need to put a comma in there to tell it that it's a tuple. If you don't, s will just equal 4. It'd just be like an int. So that's a tuple. I think they're super powerful for moving data around out of functions. It might have some other great use cases that I haven't discovered yet. I look forward to using them. The last type of collection I want to show you for now is called a dictionary. Now, a dictionary is a collection of keys and values. So you reference the value in the dictionary via its key. The easiest way to understand that is for me to actually just put together a dictionary and show you what I mean. So I'm going to use, as an example, positions in my parts dispenser that I've been working on to give you an idea of what I'm talking about. So I'm going to create a dictionary equals, use squiggly braces for a dictionary, and I need to give it a key, and then I use a colon, and then I give it the value. Now a key can be a string or it can be an int. In this case, I'm just going to do them as an int. So my key in position 1, I'm going to have some 0402 10K resistors. So that's one entry in the dictionary. I'm now going to create 2, is going to be 402 red LED. Cool. And then maybe in position 6, there's going to be APA 102. And then maybe in position 10, I'm going to have some CP 2104s. Okay, so we now have a dictionary. So what does that allow us to do? Well, I can reference the items in this dictionary multiple ways. I can grab all the keys, I can reference them by key, I can grab all the values, or I can iterate through it all as a whole. Let's start with just referencing the values from the keys. So normally in an array, you do something like D and then the index. In this case, we're actually passing it the key. So if I do 2, it's not index position 2, which is the third item in the list. It's the item that has a key 2. As you can see, 2 is 0402 red LED. Okay, let's if I want to go through and get a list of all of the values in the dictionary. Well, I can say for I in D dot values. So it's going to give me a collection of all the values from the dictionary. I'm going to print I. They're all the values. Now, what's if I want to do all the keys? Well, it's a similar thing, but I just use keys instead. It's a list of all the keys. So this doesn't seem overly useful because all I'm doing is extracting them like it's a list. But what I can do is something like this. For index, comma, part. So I'm going to extract 2 variables in d.items. So it's going to go through the whole dictionary. I want to print. I'm going to now show you how to do string formatting in MicroPython. So I'm going to print, open quotes. I'm going to use a placeholder in compartment. What I want to do is say the part is in compartment and then the index. So I do a dot format, and I just pass it the variables I want to put in those in order. So part, comma, index, and then close the bracket for the print. And now it says CP204 is in compartment 10, and so forth. So you can extract data out of a dictionary in multiple ways. Now, for those of you that know a little bit about JSON, you'll notice that a dictionary is basically what JSON uses as its definition structure. So you should be familiar with how a dictionary already works. Wow, that's a lot of stuff to take in. Once again, as I said, I've really skimmed the surface on this. I wasn't trying to do anything totally in-depth, but from this amount of information that I just gave you, you should have enough to be able to write some basic loops, conditions, store some data, extract some data from various different types of collections. And in the next video, we're going to start putting a lot of this together and start writing some actual code that does something more than print values on the screen. Thank you all for watching. I will catch you all in part 4. Bye.